Okay, everybody, welcome to the Portland PowerShell user group. Thanks everybody for coming, and thanks everybody for watching online. Tonight's subject, we're going to have Justin Grote talking about turning your PowerShell scripts into functions that you can run in the cloud. I'm pretty excited about it. I think all of us want to level up our PowerShell skills and take them to the cloud. Literally everybody I talk to wants to do that, and if you don't want to do that, I don't want to talk to you. So, there you go. Before we get started, though, I just want to thank our sponsors. Our sponsors for today are Viewpoint, as always, providing a very nice venue and providing some of the technical improvements today. So appreciate that. And to Sapient Software for providing the food. Sapient's doing great stuff for the PowerShell community, have been for a long time. If you need some PowerShell tools, do go check them out. Justin, as you'll be able to see pretty soon, has been doing PowerShell for quite a while. He's been a member for quite a while. We appreciate him coming to talk to us, and I'll let him do the rest of his introduction. Thanks.
Thanks, sir. Hello, I'm Justin Grote. I'm a Datacenter Solutions Architect with Allied Digital. Thanks for coming today, and I hope you learned something. So today we're going to talk a bit about what I call PowerShell as a service. We've all gotten our PowerShell scripts under our belt, written our little Git items, little help desk automation things. But then what if we want to take that further? What if we have these things that we want to start doing at a higher scale? And even better, what if we want to do it where we don't have to worry about things like parallelization or what servers we're going to run it on, or how do we scale those servers out? So these are a lot of questions that aren't just questions about the PowerShell community. They're about computing and programming at large. The terms commonly used as serverless computing. Obviously, the servers are still present, but it's the thought of when you're writing the stuff, you don't have to worry about where it's going to run. The server is not part of your thinking, which is why the serverless term. And so there's a lot of initiatives on this from, for Golang, JavaScript, all kinds of languages, but there's a lot growing support for that in PowerShell as well. And so it's available on major cloud providers. And what I'm going to go through today is talk a little bit about what that looks like with PowerShell and do some demos on how to do those kind of deployments. So before we go there, let's talk about a little thing that's been a real common kind of buzzword these days, which is microservices. The idea here is that traditionally when you build software or you're building a script or you're working with anything of a sufficient size, you have a team of people who are working on it, and as those things get larger and larger, they're called organizations. They're called companies who have to do things. And when you have all these different parts that have to come together, when you're trying to coordinate these things, if you have a system set up in such a way that you have to bring all those pieces together before you send it out, before you make it available, you end up with a lot of issues. You have that tight coupling that really kind of slows the process because you've got to wait on different parts, wait on different tests, wait on different teams. So a big thing that has changed in modern computing is now that we have all these different places that we can run things because we can virtualize things and put them in all kinds of different buckets to break them out in small pieces. It now lends itself to this sort of architecture where, well, maybe we can build all the different pieces independently and let them just sort of come together. As long as we very clearly define the inputs and the outputs and the APIs of how these pieces talk, then these pieces can update independently of each other. If I have an ERP planning system, the website can update independently from how the database is structured, can update independently from how we send out our invoices to customers. But they can all still interoperate, but we don't have to do a full test on the entire system across the board every single time we want to go forward. And the cloud offers a lot of advantages towards that, and that's kind of what we're going for here. So when I'm talking about this as far as how we use PowerShell, this is a lot more about how to do it in this sort of microservices type architecture. So there's a few different options here. I'm just going to lay this out as sort of an easy kind of layout for a few of them. These are sort of the main areas where you can run PowerShell as a service. What I haven't included here are some of the obvious ones, like just spinning up an EC2 instance and running the PowerShell script inside of there, or spinning up an Azure virtual machine, running it inside of there, running it on-premise. I don't include those here, although those are certainly things that you can do to fit certain niche cases as necessary. But this is sort of like the landscape as it currently exists today. So one of the newest options is Lambda. Lambda now has an option to run PowerShell. If you're not familiar with Lambda, basically it's just AWS's serverless computing platform. The main thing that kind of concentrate around these things is very little cost, is the ability to run these services, have them auto-scale out on services, but you only pay for the execution time you use. So if your script only runs for 3 seconds, you're only billed for those 3 seconds. You're not billed to run that virtual machine all day, hoping that somebody uses it sometime. And so having that more sort of consumption-based modeling and usage-based modeling can really help both bring the cost down, which then allows you to scale it out further. And I'll have an example of that a little bit later. So this was one of the newer ones. I would say it's one of the harder ones to work with the current tooling, because basically what it is was that as some engineer at Amazon, AWS started supporting .NET Core very recently. So some enterprising engineer at Amazon figured out a way to write a couple little PowerShell modules that will take a PowerShell script and compile it entirely as a .NET Core application, and then upload that .NET Core application to Lambda and run it. So the tooling is actually somewhat easy to use, but the whole process is you're basically building this full 20 meg .NET application every time you want to update a script and publish it in Lambda. So there's ways we can mitigate that we'll talk about here in a bit. So where it's very useful for is for those kind of microservices, APIs type things. When you have something that you want to present to the world, or you have an internal business case where you're trying to get some information out, it works really well for that. And it works really well in what I call what are called single page applications, where you have a certain amount of data you need to get some information, and you want to present that as a website. So things like status pages are great for it. Things where you're querying certain information and showing it. Things where you're like doing a help desk application with some simple plugins. Basically anything that you could typically do in any other language, you can now do in PowerShell, like you would typically do in like an ASP.NET type situation or anything like that. Or like Node.js. You know PowerShell, you can now sort of join those leagues. Azure Automation is sort of the grandpa of all this. Azure Automation was very early in Azure, and it basically runs on a bunch of Windows 2012 instances. Still runs PowerShell 5.0. And what it's really good for is what it says is the automation part. It has this whole section on runbooks, and those runbooks are really good for having these long-running scripts. So if you have things in Azure like you want to start up a bunch of virtual machines, or you want to check a bunch of virtual machines that they have a certain setting and they're off, or you have like a long chain of activities that you want to do, Azure Automation is great for that because you can run a script for like 3 hours and not have it stop. With Lambda and Azure Functions, sort of those microservices, you're supposed to design stuff very small, very fast, because scripts will time out in 5 minutes, 10 minutes if you change a couple settings. But basically, like, your scripts can't run very long, so you have to end up chaining them together. Azure Automation also has a really nice graphical interface. It has all kinds of graphical ways to put scripts together, upload your scripts. There's a really nice test pane. So if you've like never worked with PowerShell like in the cloud, it's a great place to start because it has a lot of really nice, friendly, GUI tools around it. So then it comes to Azure Functions. Azure Functions is just Microsoft's way to compete with AWS Lambda. Lambda came out, everybody loved it. Everybody said, Microsoft, where's yours? So then they came out with Azure Functions. Azure Functions is pretty nifty in that it runs on top of Azure App Service, which is what is used primarily to run all the IIS websites in Azure. Very powerful platform, and it basically uses a function of that called web jobs that's built on top of that, and that formed Azure Functions. And it # ends up providing a lot of really nice advantages in terms of ease of use and practice. So that's been available for a while. It's available for Java, C#, all kinds of things. The PowerShell support in it is still experimental. It's unsupported. It works just fine. We run whole portions of our company on Azure Functions version 1, and we don't have an issue with it, but don't expect to be able to call Microsoft if there's an issue. You have to self-support it. But it works great. So a real common thing with a couple of these is both the Azure Automation and Azure Functions, they still run on Windows OS hosts. So if you look at your variables, if you look at everything, if you look at sort of your interaction with the system, like you get Windowsy type stuff. The paths are Windows, the environment variables are all Windows. So with Azure Functions version 2, Microsoft actually switched it over to use Linux now that PowerShell Core has come along. So everybody here is not familiar with what PowerShell Core is. Okay, so for a quick definition, PowerShell Core is just the new version of PowerShell is PowerShell 6, and it's a way to run PowerShell that now runs anywhere, Linux, Windows, etc., because it's built on .NET Core, which runs anywhere. So really nice functionality. And so both Lambda and Functions have seen the future, also because their platforms run on Linux, so it's their only option, because the other PowerShell is not available on Linux. And so these are ones that you have there. So your scripts, basically, as long as they're PowerShell Core compatible, will run just great in those. And again, like any of those things, there's ways to mitigate them. And so that's sort of the general landscape of the different options. So if you're looking for somewhere to run PowerShell, you're going to probably end up in one of these 4 places. There's some other options, but they're not great. I mean, like, you have like your own Jenkins server you can stand up. Like I said, there's the options of just running it as a scheduled task on a computer. But like if you're serious about it, like these are the real options. So now we'll get into, what are your options for deploying this? And so to steal from a meme that we have here, you kind of have sort of a progression tree that you can work your way up this as you go. Everyone starts at manual deployment. That's the diagrams and everything that show you. I have links here for all the manual deployments, ways to get started on each of these, and these are like the step-by-step. How do you write your first Azure Lambda function? How do you write your first Azure function in PowerShell? How do you write your first Azure Automation Runbook? If you go to these links, they'll step you through that whole process. And one thing you'll notice as you go through there, like some of them are fairly like, oh, just go and get going. Some of them, like Lambda, are very involved. Like if you just want to get to the point that you can hit your script from a URL, it's about 6 different components. You have to set up Lambda, you have to set up an API gateway, you have to set up all the different components to make that work. And the tricky thing about that in an enterprise environment is, okay, you do it once. Did you write it down right? Did you document it? Can somebody else take that and repeat it? That's what gets really tricky in terms of the supportability, that kind of stuff. So a lot of people start here. Some people stay here. But when you get serious about it, you realize like there needs to be a better way. We need a way to be able to deploy this stuff in a much more robust fashion. So usually the next step most people get to is, well, I know PowerShell, so I can write a PowerShell to deploy PowerShell. And there's lots of different ways to do that. So in both AWS and Azure, there's a few different tools that you can use to start writing those things. There's the CLIs for each of them. They both have CLIs you can download that have their own syntax that you can kind of learn and get used to. It works just fine in PowerShell. I have a couple examples here where there's something that I have to cheat, that I have to go down to the CLI to use because it's not available in a tool that I use. Great tools to learn. If you were to learn any of them, I'm kind of biased here. I would recommend learning the PowerShell modules for both, because then you don't have to learn some funky CLI format here or here. These both have full feature sets of everything this can do, but it's PowerShell. So you can do everything you know in PowerShell, and you don't have to do any fancy, text interpreting or anything like that. Everything comes back as PowerShell objects. It works really well. One thing in here, too, in terms of the templating, is you can also define your infrastructure in a template file. And 2 of the biggest solutions for that right now are AWS CloudFormation templates and Azure RM templates. They're both in JSON format. And if you were to think of this like programming languages, where like PowerShell is way up here, PowerShell is built on .NET, .NET is built on C, C is built on assembler, and assembler goes to the native. The CloudFormation and Azure RM templates, those are like the C level type of this. It's not quite like the base assembly, which would be the API, but it's very detailed, very verbose code that if you ever try to write a CloudFormation template from scratch, you're going to write volumes. And just like any programming language, everything we use today you could technically write in assembly. That doesn't mean that's a good idea. That doesn't mean that it's time efficient. So we've just built abstraction layers. First we built C, then we built .NET, then we built PowerShell on top of .NET to gradually abstract things away so that I don't have to do all that work. The thing that used to take 50 lines, I've abstracted into a thing. And like when you do PowerShell, I don't want to have to write a whole thing about how to connect to this API. Somebody wrote a PowerShell module. I'm going to use that module. So again, just abstract it again. So I just have a couple commands instead of having to write the whole interface. And so this is sort of where you get when you get at this point, right? Okay, now I can like write a script that would deploy my template or deploy my virtual machine or whatever, anything in both Azure and AWS. You have a model, okay, I can deploy this. But now your problem is like, how do you manage that life cycle? Okay, I deployed it, but how do I know it's still the same as I deployed it? How do I know somebody didn't go in there and change something? If I deleted it all, how do I know that it's going to deploy again correctly? And so that's when you get to the next step of this process, which is you start getting into orchestration tools. There's lots of different orchestration tools out there. There's a very crowded landscape right now because everybody's trying to get in. You got the old hats like Puppet that have been around forever and been doing this forever, and are just like, who are these people? Like, you guys think you know what you're doing? We got this. Puppet can handle that. Puppet has direct tie-ins to those. And where this comes in handy is this aspect of state. The idea is that your script is stateless. You run it, it's procedural, it follows a procedure, and it just does it. But the next thing you want to do is start getting into a more declarative aspect, where rather than just say, I want the script to do X, Y, Z, you instead set your thing up like, I want my infrastructure to look like X, Y, Z, figure out how to do it. And the nice thing about that being is that I don't have to know how, I don't have to know how to do the API to call, to create the Lambda function, to create the API gateway, to do all that stuff. I just say, I want a Lambda function, I want a Lambda gateway, I want it to have these settings, and I just want it to work. And further, if something in that breaks, if somebody deletes this thing, I want you to be smart enough to realize that that thing was deleted and just fix that one thing. Don't delete everything and recreate it. So that's where that orchestration stuff comes in. So, Puppet's one of the older ones that's been very established, very mature. Ansible is sort of a bit more of an upstart that's a bit more procedural. They tend to have focused more on like individual like machines and managing their configuration state, but they've branched out to do a much wider like infrastructure as the cloud has become bigger. The closer upstarts are Terraform from HashiCorp, which is what I'm going to show in this example. Terraform is a declarative way to just define an infrastructure and have it figure it out. And it's very effective because it's very easy to use. It's very easy to get started. I mean, it's just a Go executable. You literally just download terraform.exe and start using it. And it is very effective at maintaining that state and tracking that state. And then a more recent upstart called Pulumi takes the idea of, the only problem with Terraform is that you have to learn Terraform's code. It's called HCI. And it's this syntax that has some programming logic built into it. It just ends up being this really hacky thing. Like, if you just need to do like a very simple definition, it's great. But if you do anything fancy, like, okay, I wanted to create this 5 times and I want to loop over it, or I want if-then statements, there's no if-then statement in it. You have to do these crazy things with counts and count Boolean alternates in order to make it work. So the idea behind Pulumi is basically do what Terraform does, but do it in a programming language. So it has full support. Like, you write it in JavaScript. You just create like JavaScript objects, and then you just start that, and then it does all that same Terraform setup, but it's defined as objects. So the reason I put Pulumi here is because they've recently started work on a .NET aspect of it, where you can use .NET with it. If it shows up in .NET, then we can use it in PowerShell. And that makes me excited, because if I could use Terraform as a PowerShell module, where I could just have my PowerShell commands say, make this, loop 1 through 5, create 5 functions, and not have to deal with the eccentricities of the Terraform format, I'm really excited. Especially also because Pulumi has already written tools that just, if a Terraform configuration has been written, or a provider or a way to use Terraform, which Terraform is a very wide audience, very big user base, you can just import that into Pulumi. It works just fine. Like, I've used it and it's great. So I'm looking forward to that one, but my examples for today will use Terraform. Primarily because Terraform is very easy to use. It's just a single executable. It doesn't require any kind of server infrastructure, which things like Puppet and Chef and et cetera use. So it's really easy to get started, and it's right there in my example. So then you have things that are specialized just on the serverless. So where we were talking about, like CloudFormation, CloudFormation and Azure RM templates being sort of like the C level, like Terraform, Puppet, et cetera. Those are like the C++ level. Those are like the .NET level where, okay, we're not working with like the raw configurations, but we have a more abstracted way to define this stuff that makes a little more sense, and then it turns around and does all that stuff and creates all that kind of stuff. So the specialist guys go a step above that. The specialist tools like Serverless, Stackery, and AWS Serverless Application Model, these are ones that are specifically for deploying this kind of infrastructure as code type stuff, which is what you'd be doing with Azure Functions. So basically what it boils down to is a Terraform config that is like this long, which I'll show you, to deploy just one Azure function is like this long in serverless, because it's tailored for that, so they've written it in such a way to take out a lot of the boilerplate type stuff. Stackery is very similar too. Stackery has a very nice like graphical interface. It's really nice to be able to like take it and like drag and drop your functions and connect your functions together through pipes and all that kind of stuff, and then it'll figure out the code for you on the back end. And then AWS SAM is just, again, like it's another sort of templating language. It uses YAML. It's a lot like Terraform, but it's very AWS specific. You can't use it. Terraform you can use for pretty much anything, so you learn Terraform. Just like, I like Terraform because it kind of matches the PowerShell promise, where you learn PowerShell once and it's the same no matter where you do it. The problem with learning like an AWS specific tool is if you want to do it on Azure, you can't use it. You got to learn a new tool and figure out the differences. Terraform, you learn it once, you can use it on Azure, you can use it on AWS, et cetera. And that's the promise of Pulumi too as well. And serverless as well. So serverless, I'm not going to show a demo on here, but I can do a later presentation on using serverless to deploy Azure Functions. But it's basically the same as Terraform, it's just less code. It looks a lot nicer. So then once you're at that point, okay, you're at this point, you have a configuration program that can go out, it can see the changes, it can keep your code immutable, it can be idempotent, which basically means that I can run it multiple times, and I don't have to worry about it clobbering or creating multiple copies of the same thing that I already had, whereas if I did it procedurally in just a script, it might do. I don't want to have to write all the checks to make sure this thing is there, I just want it to handle it. Then that's great. If you're at that orchestration level, it's really easy to just jump right in at that point. And then the next step after that is, okay, now that I'm at that point, I want to make sure that, how do I make sure that changes that go into the system get controlled, they get reviewed, they get peer approved, and that when they go out, then every time we make a change, that the system is a reflection of that change, so that you have true infrastructure as code. When I change the number of servers I have in this pool from 5 to 7 in the code, as soon as I hit commit, and that commit gets approved to go into the master code base, the second that happens, kick off those orchestration tools to then change the production, so that my production always is like within minutes exactly what my code base is. And what's great about that is that it's self-documenting, is we don't have to keep all our little notes about like, oh, well, this server we had to make these little changes here, and this server we actually had to change this little INI file, and so we don't have it there. No, we make those changes in the code, and then the code is self-documenting. What is in the code is what is out there. And it's a lot of this term, that's another term you might hear, cattle, not pets. The idea is trying to set stuff up so that you can just destroy it and recreate it as you need to, and not have that one server that's like the one server that's like Windows 2003 that nobody wants to touch because it'll break everything, but it's a pet. We have no way to replicate it. We have no way to duplicate it. We have no idea what somebody did to that to make it work. By moving to more of an infrastructure as code type layout and doing that with your PowerShell scripts, I'm not talking just your infrastructure, but just like your code base for onboarding new users, your code base for accessing an API and getting some information into another system, your glue code. This doesn't just have to be a deployment infrastructure with a bunch of virtual machines, and I'll show what that looks like. So when you get to that point of continuous deployment, a lot of options here. These are basically tools that once you have that repository where you're keeping your data, and that can be GitHub or Azure DevOps or anywhere you want to keep code. These are tools that then, as you make changes there, they pick up on it and then do whatever you want. They've been typically used for things like, like building the code, testing it, making sure it's a zip, but you can take it a step further and actually have that do a release process where not only does it build the code, check your code that it's okay, your PowerShell code, but then push it out to Lambda or push it out to Azure Functions and have it be available. Do a stepwise process where it pushes out the code but only makes it available to 5% of the user base at a time. You can make sure 5% of the requests go there and it's working, and then you can like dial it up over time without having to do like a risky cutover process or anything like that. All this stuff that you probably hear like developers and stuff doing with really fancy hotshot DevOps type stuff, you can do with PowerShell. And we do it every day. I guess let me go back real quick. So of these tools, these days, I used to be a big fan of AppBear, and still am. AppBear is a great product, but Microsoft, when they did their Azure DevOps rebrand, the Azure Pipelines has come a long way. They basically saw what AppBear was doing, and they took on a lot of the knowledge. So they do a great job of being able to define everything about your pipeline. Again, just as code in your file. You don't have to do a bunch of graphical stuff. And the big thing I like at these days is it's really fast for starting things. The problem about AppBear is still a company. They don't have the resources of Microsoft, and even though they kind of work on a cloud, a lot of times when I start build jobs and stuff, I have to wait like 5-10 minutes for something to get queued and get released. Whereas with Microsoft, their Azure Pipelines is designed to be, every time I start something, like it's within a second that is now working on it. And there's a lot of integration there. I mean, Microsoft has invested a ton there. So if you don't want to write all the code, you just want to have some easy snap-ins to like connect to Microsoft Teams or publish it to this space, you have to learn the PowerShell code to do that. They have nice little graphical wizards to do all that, and then they'll dump it down in for you. So I'm a big fan of Azure. Also, it's free. That helps. It's free, totally free. So there's a lot of different ways. Jenkins is probably the most common, and Travis are probably the most common ways to do it. Like if you're in an environment that you're still on premise and you still want to do some of this kind of stuff, but you can't have your cloud talk to your environment, or you're in an environment that doesn't allow anything outside, you can still do a lot of this kind of stuff with just one of these systems that you can just implement on premise. And the nice thing about things like Azure Pipelines is as long as that server you can do all that stuff in Azure Pipelines and have it do the work on a server that you keep locally. You just install an agent on it. And as long as it's allowed just to talk out to Azure Pipelines can push down all the code but still do everything inside your environment. That's what we do. So we have both the cloud runners, which run a lot of the stuff that push out all like the public API stuff, but then we have a couple agents for a couple code bases that when we update the PowerShell scripts for them, it pushes to our internal systems or the internal systems of our clients and runs it there and then pushes. And that guy, it's firewalled as such that that guy can only talk to pipelines just for that work, and then it can only talk to the specific things that it needs to do. So we can still keep it secure. So that's basically sort of like what that timeline looks like, is that this is not unique to PowerShell, but this is sort of like what the modern computing sort of dynamic looks like. Is, you start out writing your basic code, and this is just like setting up individual servers. And then you went to templating, you went to virtual machines if you're an infrastructure guy. Then you went to orchestration, you went to tools that manage the life cycle, like VMware Cloud Manager and such like that. And then you got to the point, not a lot of people get to the last point, but then you get to the point where, people can self-service on demand their own systems, and they're ready and they're available there. This is just, because we've been able to abstract away from the hardware so much these days, it doesn't matter where you run it. And if you can get it to the point where it doesn't matter where you run it, then that opens you up to a lot of possibility and a lot of flexibility. So here's an example of what you can do with this. You can build a virtual machine. Typically, here's a use case that we had a particular system where we just had to integrate 2 ticketing systems. We had a ticketing system where as alerts came in on one, it had to take it, do a little bit of parsing, get it in the format that the other ticketing system wanted to have, and then submit it to its API. So we wrote that, about 80 lines of PowerShell code, just wrote it in PowerShell, tested it, made sure it worked, put it up in Azure Functions, and then set that as a webhook, and I'll show what that looks like. I'll show an example of that using an HP warranty thing I did for a way to just get HP warranties easy. Hook it, just takes it in and puts it out. So that sense, with production, it does about 12,000 executions per month. That's 12,000 tickets that get created here, show up here, pass through, go out the other side. Average execution time is about 400 milliseconds. If you were typically building a system like that, you'd have to stand up a server. You'd have to probably stand up 2 for redundancy. You'd have to implement a load balancer in order to be able to manage those. You would have to maybe build 3 or 4 servers to handle those peak workloads, and then the rest of the time it's not available. And you would have to pay somebody with the expertise to do all that stuff for you. Well, how much would that cost? $50,000, $60,000 plus labor. This is what it costs us every month to do this. And the deployment, I'll show you how it works. It's literally, you just run one commit. We don't even, when we do it, we just commit. Like, okay, these guys added a new field here. They need the HTML from here to be parsed so that it shows red in another field. This is an exact example of something that had to be done. Okay, guy went in there, made the change, made it as a pull request, submitted it, everybody reviewed it, it went in the background, built it, did mocks on both sides, tested a ticket without actually touching production, saying, okay, this looks good, sent it to state, and then all that happened automatically in the continuous development. And then so we all see it passes the build check, everybody reviews the code, okay, looks good, we all approve it. It then goes to staging, as soon as we approve it. As soon as it goes into staging, stands up the exact same environment, exact same system, clones of the other 2 systems that are generated daily with production data. They're silently cloned in the background and created, and then that runs. And then it runs for about a day, and we make sure that everything's good there. And then once that works, then it goes to production. And then what happens is we use a function in Azure Functions called slots, where basically the old code is still there, the new code comes in, and the new code gets automatically directed 5% of the requests. So of these 11,000 tickets, the new code is now handling like 400 of them. And so as they come in, just every once in a while they come through there, we watch it, we make sure that it's working, that it's performing correctly, all that stuff. Then we dial it up, 20%, 30%, 40%, 50%, till eventually this new one takes over, the old one sunsets, but that's it. There's no cutover, there's no cold startup times of waiting for the new system to get everything cached and warmed up. We're able to do that and constantly just roll through production new changes with 0 downtime. That's all done in PowerShell, and that's all stuff that we do just with code, just in serverless, just in basically Visual Studio Code and a Git repository. You don't need anything fancier than that. And again, those are our execution costs that I calculated, but technically Azure Functions gives you 1 million execution gigabytes per second per month. So technically this is free. But I just ran the calculation for what it would have been if we actually were paying for it. So that's a pretty big value use case. So what I'm going to show here is I'm going to show a bit of the Terraform stuff that I was talking about, and I'm just going to I have a very simple example here, and this is a Git repository that I'll provide to you guys. There's a very simple step-by-step that I'll show you here that will step you through just taking a Hello World script and deploying it in Azure Automation, Azure Functions, and Aws Lambda for yourself. Because again, we've set this up to be abstracted to use Terraform. All you got to do is give it set up an AWS account, it's free. Set up an Azure account, it's free, $200 a month, and then run this, and it will build this script everywhere, and you can test it and play with it. And in all these cases, it all falls under the free tier, so you can leave it out there. You might build a couple cents for the cloud shell, but It's under like $1. So if you can't swing that, then don't run it. But so the first thing I'm going to do is go to my little dev instance here and sign into my Cloud Shell. Do you guys all know what Azure Cloud Shell is? So Azure Cloud Shell is great. Basically, I'm going to bring it up here. It's just PowerShell in the cloud. Let me sign in here. It's going to make me want to do my two-factor authentication because I'm a super smart, savvy multi-factor authentication guy. The notification says sign in. Yeah, that's fine. I am who I say I am. And just a couple seconds here. I have a PowerShell prompt in a web browser. So this is actually just this is an instance of PowerShell running in a Linux container in Microsoft Azure. And it's really easy to set up. Like if you have Azure today or you sign up for Azure, you just hit this button right here. You'll see this button, Cloud Shell. You just click that, and bam. And you don't have to set anything up. Like you have logged into Azure for the first time, and it will set everything up for you. It basically just sets up a little storage account to keep everything you do in Cloud Shell, for files that you add and that kind of thing. But that's it. And now I have PowerShell. It's PowerShell. I got PS version table. There's my PowerShell. It's 6.1.3 PowerShell Core. It's everything PowerShell that you can normally have. Get the PS drive. Got all my little drives here. I got my root drive, which keeps everything there. I got my Azure drive, which is a special drive that you can browse Azure objects like they were files. So you can go in, you can go literally browse it like a file system and create new file virtual machine. It will build a virtual machine. Remove a virtual machine file with with git child item pipe remove item, just like you do in a file system. It'll delete that virtual machine. That's done with this thing called system hierarchy in PowerShell. It's basically a way to write these kind of things in PowerShell, and it's really cool. And I really hope it gets more and more use. Like I've written a couple of them. I wrote one for one of our network monitoring systems, where basically our techs can just browse a tree and see the devices that are in the monitoring system, add new devices and remove them, just like they were adding and removing files. It's great. So here's the sort of one place of a Cloud Drive. Another place you can run Cloud Drive is Visual Studio Code. If you're using PowerShell ISE, I recommend you at least give this a try. Visual Studio Code is awesome. It's Notepad on steroids and then some. But one thing you can do here is you just have to get the Azure account extension. And then right here, you'll see here, one of the options is Open PowerShell. I should show that again, Control-Shift-P, which you probably saw. That's just the quick way in this to get to everything. So you have Azure, Open PowerShell, and Cloud Shell. And coming up right there is my Cloud Shell. Exact same Cloud Shells I have running in the other spot. So if you don't want to open a web browser and do it, you can do it here. So before you do that, when you install the Azure accounts for the first time, you do an Azure login. Yeah. Oh, I'm sorry. So the question was, how did it authenticate? How did it know that it was me? And what happens is that there's an extension over here that you first install. I'll just do this real quick. So this Azure account extension, this is what gives you access to Cloud Shell, as well as a bunch of other stuff. So when you install this extension, one of the first things you do is you do a sign-in. And then it'll open up a web browser. You do your typical Azure sign-in. Oh, did it lose my internet connection? No, I'm still good. Maybe the firewall here is blocking it, whatever. But it just does a sign-in, and then you have access to it there. So it's pretty simple, pretty straightforward. But then you can do all your testing and that kind of stuff in the Cloud Shell here. But I'm going to use the one in the web browser because this is the one that most people will probably be using. And so let me just go to my GitHub real quick for the PowerShell demo. Yeah, in Visual Studio Code, there's a thing that they added called screencast mode. See this toggle screencast mode? And so if you turn that on whenever you're working in Visual Studio Code, yeah, it shows you everything that you're doing. Handy for screencasts, will show where you click, that kind of thing. Yeah. So yeah, that's a Visual Studio Code specific thing. You'll notice when I go somewhere else, it probably won't do it. But so I have this repository. Also, you'll probably notice everything's dark themed. There's the newest version of Windows, this is Explorer, comes with a dark theme now, and it's great. So if you haven't seen it, try it out. You just toggle it. But there's a Chrome extension that lets you sort of match everything as well. So if you wonder why my GitHub looks all weird, that's why. I don't like burning out my eyes. So this is the repository, which we'll put in the notes, but basically this is my, just a GitHub repository that I'm going to show you the demo from. And then it has all the getting started here, but literally here's a button for just launch Cloudshell. And it takes you to that URL, and again, if you don't have an Azure account, it'll just ask you to sign in or create one, and then within just a couple seconds, you'll have PowerShell ready to go in Azure. So I'm just going to switch to my root folder here. Let me make that a bit bigger, if I can. It might not let me. There we go. Okay. So I have previously gone here and checked out this from my GitHub. I just did a git checkout in the URL. So in this folder are all these different files. So using this, I'm using a thing called Invoke build, which if you're familiar with Saki or anything like that, it's just a way that you use for building. The nice thing about Invoke build is you can use it for anything. Like it's really handy for basically like, it's basically a way that you can build functions and very easily define like the dependencies between those functions. And I'll show a little bit more of that, what I mean. But this is just going to be for the demo. So right here I have my little demo script, demoscript.ps1. So it brings up my little demo thing here. And so this is just going to step through a few things, and I'm going to show what that demo script looks like. Blow this up a bit. Okay. You see that okay? All right. So this demo script, basically I just made this little kind of quick function to kind of do this kind of fancy little text like you saw there. And then it's just going to step through each step and run each command on each one. So first, we're going to make sure our environment's good. And basically, this is going to run the test step of my Invoke build script, which I'll show you in a minute. So this is just going to make sure that, like, have I configured AWS keys correctly? Am I in an Azure environment? The nice thing about Cloudshell is because you logged in with Cloudshell, you don't have to set up the Azure CLI. It already knows who you are, and it will run commands as you, unless you give it something else to run as, like a managed service identity or something like that. So that one will be an easy test to pass. And make sure all the extra software is there. So this next one will be install prerequisites. This uses a PowerShell module called ps-depend, which just makes it really easy to write a little quick config file to say, I want these prerequisites to be installed, I want these PowerShell modules, I want this .NET framework, etc. And I've already warmed up my Cloudshell environment, so we'll step through that pretty quick. So the next thing I'll do is I want to deploy into AWS Lambda my example script. I actually didn't get the HP warranty for the Lambda going, but just that example. So it'll get to that step, it'll run the example, and then that'll run that step, which will basically kick off the Terraform, which you can see the Terraform files over here, which I'll go through here in a minute. But basically this PowerShell will then just, I have this example script here under examples, my AWS Lambda example, and it's a real complicated one, hello world. There's a little bit of extra comments here to kind of give you an idea of like some of the environment in Lambda and how to use it. But this is just going to be a hello world script. And same thing for Azure Automation, it's just a simple hello world script. In Azure Functions, I have my little hello world script. Again, very straightforward. And then I have a little bit more complicated one because people get sick of hello scripts. So this is one that, again, it's not very complicated. It just runs one PowerShell command. But it runs a PowerShell command that I wrote that uses an HP API to go out based on a product and serial number, get all the warranty detail about that system. Because big problem with HP is that there is no API for this. Actually, I wrote a screen scraper, and there's an undocumented Insight remote support that I was able to get to that pulls this information. But man, when you work at a company like mine, which manages a ton of IT departments, being able to have a PowerShell command that you can run a network discovery, get every single thousands and thousands of HP servers. Without this, I have to go to the HP warranty. HP tells me what I need to do is I need to go to their website, and I need to type every one into this little field, hit submit, somehow take that data out, put it in Excel or something so that I can use it. Or we can have our script do all that, and it does this daily, pulls all those thousands of warranties, has a cache, and any net new ones, it just runs, it goes out, it calls an Azure function, which I'll show you here, to just grab the warranty information, gets it in a couple seconds from HP, and then loads it into our database, and our staff can just run a query. It's like, oh, these servers are 6 months from expiring. We don't even need to involve HP for that. We don't need to use their proprietary tools. And now we do that for HP, we do that for Dell, we do that for Cisco, we do that for Talar, we do that for every vendor that our customers cover, as long as we have some way of getting at that information. And it doesn't have to be an official one, which I'll show here in a minute. So the script will do that, and then we're just going to repeat the same thing in Azure Automation, then repeat the same thing in Azure Functions, and then once it's all done, we're going to tear it all down. And that's the part that I wanted to show too as well, is the nice thing about using orchestration tools like Terraform is they keep track of what you build. So you build a bunch of stuff out there. How many environments have you walked into where there's test server 1, please delete, or really critical thing, do not delete, that doesn't appear to be doing anything that nobody has any idea about. Or I just made this for a test, or example 7, but it's actually running production data because that's the one they got it to work on, and they don't want to try to reproduce it somewhere else. That's called drift, and this is a way to help manage that drift, is because if you do everything in Terraform or another tool like it, then it keeps track of everything you create. And if you change something, again, you change it in a declarative way, okay, I don't need this Azure function, but I need this Azure function now, or now I need this piece, or now I need 5 Azure functions, or now I'm going to change this piece, and if any of this stuff is dependent on it, I'm just going to say I'm going to change this piece. You figure out if it's important or not to change or not, and that's what Terraform does. Terraform will see that you change this piece, look at the dependencies, and say, oh, you changed this virtual machine image. That means all these virtual machines have to be recreated to use the new image. But I didn't tell it, recreate these 5 virtual machines. I just told it, I'm changing this image. And then it tells you, I'll show you the plan that it shows where it says, okay, I made this change. Here's what I'm going to do based on what you want. And then it just goes out and does it. Really slick stuff. It also figures out all the dependencies for you. Like when you write the code, like it doesn't matter what order they're in, it'll figure it out. Like if this thing's dependent on the other thing, just by the way that you reference things together, if this thing's dependent on the other thing, it'll just figure it out. So you can put it before it, put it after, it doesn't matter, it'll figure it out. So that's basically what this script is going to do, so we're going to go and fire it up. So first thing we're going to do, make sure our environment's good. And this kicks off a Pester test. Pester is just a very simple PowerShell module. Well, it's not a simple PowerShell module, but it's a way to run tests. And so a lot of people use it for unit testing, which is like testing code. But you can use it to test infrastructure. You can run any PowerShell command you want and just test it. So I just have it do a little quick test. Are we in PowerShell Core? Some of the stuff I do doesn't work in Windows PowerShell, like using the AZ module. Okay, great. Do I have the AZ accounts PowerShell module? Because this isn't going to get very far if I don't. Okay, great, I do. Do I have the Azure CLI installed? Because I'm going to need that first step. Great. Am I logged into Azure? Because I might have all this stuff installed but not actually logged in. It's not going to do me any good. Great, I am. And you notice over here it shows all the times it took to test all these things too. And then is Terraform installed? Because I'm going to use Terraform. Great. So all of that is just written as a Pester test. And they read pretty easy to read. You know, it's just in PowerShell Core, is core CLR true? You know, Terraform installed. Terraform should not be null or empty. And so it's an easy way to just test, hey, sanity checks before I do this and potentially like build a halfway environment to make sure everything's there first. So I wrote one for AWS and one for Azure. And then down here is, you can't quite see it there, but the build.ps1, this is an Invoke build script. These basically are just, you write a task, you name the task, you say whatever things that task is dependent on, and then it'll figure out all the dependencies and what order to run things and not repeat things that have already been run, and then do what you want. So we're up here at this step at the test AWS. So we just ran a test. It just says, run this Pester test. If any of them fail, crash the build, or crash the program. So that, okay, now I got to fix that stuff and go forward. Okay, so we got through that step, and this kind of skips around, so it's not easy to read. But so we got through that, did our Azure tests, did our AWS tests. Are we in PowerShell? Yeah. Are we in Terraform? Yeah. Did I configure my secret key so that I can do this stuff in my environment? Yeah. Is the Aws Lambda PowerShell module installed so I can do the PowerShell Lambda things? Great. Okay, so we're good. That all succeeded. So now we're at the next step. We're ready to install our prerequisites. So now this is just going to run that PS depend that I mentioned earlier. Where did you go? So that's this requirements.ps1. So I said, all right, I just want to have the latest version of Lambda PS Core, and I want to have the latest version of Pester, which is all I need for this example. So that's what it's doing right now. Go back to my Cloud Shell. Okay, great. That completed just fine. So now we're ready to do our next thing. We're ready to go ahead and deploy both my example function and my HP function in Azure Functions. So to show my little magic trick here, I'm just going to go to my function apps and just see. There's nothing here. It's completely blank. I'm actually baking the cake now. So I'm going to go, okay, let's go ahead and start building it. So some stuff's going to fly by here real fast. So first, again, going to do that test again, just to make sure. And now we're actually going to build the actual Lambda module. And And so what this does is that there's a step in this process. Back to my build script here. So we're going to go here, down here to Terraform AWS Lambda. So in this process, we're basically going to build a Lambda package. So all this is the command. This is all straight from the documentation that I linked on the first page for the manual. Is all you do is when you make a PowerShell script for, once you have a PowerShell script you want to run in Lambda, you just run this command to build a package. And this is the step that does all this .NET stuff that you saw in the background. It's literally building a C# .NET Core 2.1 application and putting it in a zip so that it can be uploaded to .NET, or upload to Lambda. Because Lambda doesn't actually speak PowerShell, it speaks .NET Core. And this just puts a wrapper around it in order for it to run that PowerShell script. So we'll get back here, my Cloud Shell. Get to the right Cloud Shell. Where'd it go? I didn't sign on that account. Must have refreshed on it. Well, hopefully it completed. If not, I wrote it in such a way that because we use these tools, it can figure out what didn't run and do it again. Did I lose my internet connection? I have to tether off my phone here. This Wi-Fi is not happy with me. Pull it out of my old database here. Oh, yeah, let me tether it off my phone here real quick, and I knew I should have done that in the first place. Guess Wi-Fi thing is not happy with me. So yeah, as it runs there in the Cloud Shell, it'll complete, and then we'll be able to see it here in a minute. I'll just connect to my tether guy here. All right, let's get back to my shell. That's better. All right, let's run this again. Demo script. Do our base test. All looks good. Do our dependencies. All looks good. And then do our Lambda. So it's going to do the same thing. See, there it goes. So now it's actually doing that .NET build, as I see. See how it's generating a C# project? It's basically just taking that one script and building all the .NET stuff around it, putting in the PowerShell .NET libraries, all that stuff, building it into about a 10 meg package, and then upload to Lambda. I put this example first because it's the most cumbersome. And hopefully there's a thing called layers that has been added to AWS that should make this easier, but it's currently not a thing. Okay, so let's go back up here. So now we have this, and at this point, it built the package, and that package is available. The next step, we're actually starting Terraform. The first thing we're doing is initializing Terraform, then it's going in and checking, and then seeing, okay, we need to build this function. So this is that plan thing that I was talking about. And what happened is actually, I think when this was running in the Cloud Shell before, it actually went in there and created it. So that's why it's, it's not saying build everything, because there's 17 things here. Let me actually show you what the Terraform looks like. So in my Lambda Terraform, I want to build an AWS caller identity. I want to build a REST API. I want to build a gateway resource. I want to build a gateway method. I want to build a gateway integration, which integrates the method to the integration. I need permissions for that to work, defines all that stuff. And then I finally have like my actual function. Like this is the core. So this function says, build a function. Take that package that I built. I actually, in the Invoke build script, it actually like passes it to this Terraform. So take that file I built, give it the name that I specified earlier, give it that particular role that got built up there earlier. It's referenced. Give it the particular handler name. Don't worry about that part. That's basically tells Lambda, because it's a C# thing, hey, how do I start this thing? This basically says, here's how you start it to run it as a PowerShell script. I want it to be in .NET Core 2.1, which is what we do to run it in there. And then take the hash of it, the source code hash. And the reason that source code hash is there is that if I go in there and change the code, that's how Terraform knows, oh, this zip file changed. That means it has to be uploaded and updated, which in fact, I did just rebuild it, as you saw. And so if you look here, the only thing to do in the process is update the file. See, it says the AWS Lambda function .this. I use this because it's just easy. You can name it whatever you want. And it was recently modified. So because I just deployed it maybe like, 3 minutes ago, well, now I'm running it again. I made a change because I recompiled it. Okay, but Terraform is smart enough to know, oh, I don't have to delete and recreate everything, or I don't have to know. It already knows what's been created, and it just changes what I changed. I didn't have to tell it, like, oh, I need you to update the Lambda function. I didn't do that. All I did was change the file. And it knows smart enough to say, oh, this file changed, and I know that this file is part of this function, so therefore I need to update the file. That's the power of a declarative language over a procedural language. If you use PowerShell DSC, exact same thing, desired state configuration. You say how you want it to be, but you don't tell PowerShell how to get there. It's supposed to figure it out. And that kind of declarative tools are really nice because you just define, this is what I want it to look like. If somebody screws it up, if somebody changes a file, somebody goes in there and edits that file, or they delete my function, which I can show you. If somebody accidentally goes, oopsies, deletes the function, well, if the continuous deployment is running, it's going to see that that thing is gone and recreate it. That's Puppet's bread and butter, too. If you want to see some real mature work in that, this is the guy to talk to. So now I got that. Okay, great. I got my AWS Lambda function built, and I can actually go out here to AWS. I think I have a link right to the Lambda console. And there's my little demo function. And it's already been built. It's there. It's all tied in. It's got all its goodies. I run my little test. Now, the first time you run a function, it's got to actually like fire it up, start up the virtual machine, allocate it. It's what's called a cold start. Typically, when we do these kind of things, like we just have a script running in the background that like starts it every minute just to make sure it stays warmed up. So this first run took about 6.6 seconds, but there it is. Hello world. Here's my script. Run it again. Oh, okay, that only took 70 milliseconds because it's up and running. It's ready to go. So this actually has a website URL that you can go to because all that API gateway stuff was to build that hook that you can just go to the website and it'll reply back hello world. Now, websites are the ones that I do because that's the one that most people understand, but you can hook that to so many things. You can have it trigger when a file gets written to an S3 volume. You can have it trigger when somebody says, say hello to PowerShell into their Amazon Alexa, and the Alexa is configured to go to that trigger point. You can have it do it whenever a log file is written on your server that says there was an unauthorized login. Like, again, you can hook it to anything, and you can chain them together. I could have this hello world instead of just output hello world. I could have it write hello world into a queue, and then another script is watching that queue to then take that queue, and you see how this goes? This is like a factory assembly line. That's where the microservices part comes in, is that I only need to know my part. I only need to know how to take this thing and dump it into the queue. As long as we've agreed on what the queue format is, I don't have to care. That's that guy's job. And so that allows us to do big division of labor, but also because I've deployed in a service environment, it doesn't matter if I get one of them or if I get 1,000 of them. If I hit submit 1,000 times on this thing, or I write a script to hit it 1,000 times, I can show you this graph that will show this Lambda function and go, oh, crap, I'm getting 1,000 requests. Deploy 15 workers to handle this one hello world script and then handle it. And it just works. I mean, I didn't have to do any of that. I didn't have to design it. I didn't have to scale it. I didn't have to design AWS auto scale sets. I didn't have to write the scaling rule, although you can customize all that stuff. It's just handled for me. That's the idea of the serverless part of this, is that it's not that the server's not there, it's just I don't have to think about it. I just write the code and let AWS handle it. Or Azure, as you will. So that's the example in Lambda. And Lambda is the most popular at this point, so this is the way to get your PowerShell into there. You know, you can take that exact same code that I have, change hello world to something else, run it in your environment, and as long as you put in your AWS codes, you will get this posh AAS demo show up in your Lambda function site with your code, and you can hit run and have it work. Okay, so let's do that with the next process. Let's look at, if the thing hasn't timed out on me by now. Okay, so now we're ready to do it in Azure Automation. Okay, let's see what that looks like. Here, again, just Terraform. Once I learned Terraform once, I was like, okay, I figured out how to do it for Lambda. Most of this is a nifty thing. If you get the extension for VS Code, it does all the formatting, it does all the linting, but for every resource, you see how it's underlined there? If I control-click it, it will pull up the documentation for that function and an example. So I do this all the friggin' time, where I'm like, what's the thing? Control-click. Okay, great. I wish I could do that with PowerShell. I wish I could just like take a PowerShell. I do git member all the time, but I wish I could just control-click, all right, give me the documentation. I guess I'll have to write that into the PowerShell. I got to learn TypeScript to do that. I'm not a very good TypeScript guy. So yeah, that tangent aside, we have, okay, so here's our Azure Automation one. A little bit simpler. So with Azure Automation, we just have a couple providers. I say, okay, I want Azure RM, which is the provider for Terraform to do Azure stuff. And then I have local because I'm actually going to pull a zip file. I'm going to pull that file in that I wrote. And so, and then I have a variable name. And the reason I make it a variable is like, if I want to run this, but say I want it to be demo2 or demo test or demo prod, I only have to change it this one place or input it to Terraform in this one place and have it do everything else. That's how our stuff works in our continuous deployment. We have it in Terraform. You know, the thing kicks off Terraform, but when I talked about how like it goes to staging and then it goes to prod, we don't have an entire code base for staging versus an entire code base for prod. It's the exact same code base with a couple variables tweaked, and then it deploys it appropriately. That's the other great thing about you know, the cloud stuff, is you can stand up $1 million infrastructures and tear them down in 5 minutes and only get billed $5 for it. So I got a resource group. If you're not familiar with Azure resource groups, it's just a way to organize things in Azure. It's basically a folder. And then, okay, I'm going to create my automation account because I didn't have one already. If I already had an automation account and I just wanted to create scripts inside the automation account as runbooks, you can just reference that later. Here's my automation example, PS1, which I showed you earlier. That's just the hello world script. And you notice like this stuff isn't in any particular order. It's just however I want it to be. Because it will figure out, because I referenced this from this, okay, I need to process this first. That's a nifty thing about Terraform. And declarative tools like this is basically it automatically looks at the variables and what you've referenced and builds a dependency tree and then runs it in that order. Same thing with like that invoke build script. You know, it's like the test was up here, the other functions were down here. But whenever I hit enter and it does the invoke build thing, it still does them in the right order because it's based on those dependencies that I put in there. I said, before I do a publish AWS, always do a test. If I do them all at the same time, so I'm doing them step by step, but I'll show you me running them all at once. If I run them all at once, okay, well, if I'm doing both Azure and this, you only need to run the test the one time for Azure. Like, I don't need you to run it every single time. Once it's run once, you can automatically figure out and not do it. Great thing about invoke build. Yeah? No, DSC goes top to bottom. DSC is not smart enough to do that, unfortunately. Yeah. Oh, so, I'm sorry. So the question was, does PowerShell DSC desired state configuration work the same way that Terraform does in terms of it doesn't matter what order you put it in? And the answer is no. DSC in and of itself works procedurally top to bottom. But DSC is smart enough, based on the get set test, if you actually ever write DSC, it's smart enough to know if you've done something already and skip over it. But DSC you have to write in order. DSC does, let me codify that. DSC does have a depends on statement. So you can manually do it. You can say, this statement depends on this one, and even if you put it up top, it will move it down. But it doesn't have any kind of automatic way to do the glue like Terraform does. Not a lot of stuff does. It's one of the really great things about Terraform. It's like, I don't have to write all the dependencies manually. It infers it from the references. If this thing refers to this, it's clearly dependent on it. It's really smart. So here's like the meat of it. Here's the runbook. All the other stuff is scaffolding. It's my account, it's my resource groups, et cetera, and then you see where this stuff starts getting pulled in. So I have my name in my runbook up top there. I have the location, which is the resource group, basically. I have the resource group name, which, again, when you see that dollar parentheses, then I'm just referencing the thing I created up above. It was called Azure RM Resource Group Example. So So I'm referencing that, and I want the property location out of it, just like you would do PowerShell like dots to get the attributes off things. Properties, excuse me. I want to log verbose. I want to log the progress. I want to have a description, and it's a PowerShell runbook versus like a workflow or something like that. And then this is just an eccentricity. Like you have to give it like this link, because typically you can have it like pull from like an S3 bucket or pull from an Azure storage account. But you can also feed it directly, but if you do that, you have to put this like dummy URL in there. So this could be google.com or whatever. Just has to be something that it can resolve. This is just, I put eccentricity here because like this is dumb, but you have to do it or it will break. You guys have never had anything like that in your code, right? Never had anything where like this is dumb, but you have to do it or it'll break. I know it's dumb, but don't worry about it. And then finally I have my content, which is that data local file up here, which is this local file, and then the content of it, which is the actual script. So what this is just going to do is step through that article on that first page of those manual things. There's an article that walks through this, and it's like 37 steps. And you'll watch this thing do it in just a couple minutes. By the way, you saw how fast that AWS one was good? It's because Amazon did a great job with the AWS API, and it's always really, really fast. Some of these Azure ones might take forever because it's incredibly inconsistent. Sometimes it takes a little while. Like something about what Microsoft does in the back end there, it's very inconsistent. It's a little annoying, but you know, you deal with it. Yeah. So this one you'll actually be able to see because I don't think I've run it yet. I'll let it get through the tests, and now it's going to do Terraform. Terraform's going to initialize. It's going to go out and fetch the RM and everything. It's going to refresh that data. Okay, so before I let it get to it's going to go ahead and do the rest of the stuff. I'm going to show this. So this is what's called the Terraform Plan, where it says, here's the execution plan. Here's what I'm going to do. The plus means create. So I'm going to, based on what you told me you want to do, I went out and I looked at what's out there. I saw that there's nothing out there in Azure. And so you want to create an Azure automation account. Great. You want to create a runbook with this name. Great. And you want that resource group with that, great, and then wherever the content is. And your content, hey, look, it's that content that it pulled it straight out of that script. I didn't write that in the Terraform. It pulled it straight out of the script. That could be like a big, long thing, too. And so now you know that content, now that it can see it, if I ever change that script and run this again, it goes, oh, you changed your script. That must mean you want it uploaded to Azure Automation as your most recent copy. But I don't have to tell it that. I don't have to run the command. I don't have to worry that I messed it up. Terraform will just figure it out for me. I know there's a lot of talk about Terraform, you know, there's a PowerShell group, but I'm using it to deploy PowerShell. So, and there's lots of other tools that do this. It's just Terraform's the easiest to get started with, I think. So then here it is. And so now once done that, I saved the plan to a file, and then the very next thing I did was Terraform Apply. If you do this at the command line, typically what you do is you do an apply, and it'll show you what it's going to do, and then of course it prompts you, like, are you sure you want to do this? But I've taken the manual steps out of this. So then here's where it goes. It's creating. Okay, you want to create this group? Great, created it. You want to create this automation account? Great, I created it. Want to create this runbook? Great, I created it. And then it tells you the object that it created. There's your Azure reference. And then I put this little thing in there for the outputs. I was like, just as an easy summary, give me the name of this thing. So like if you were using Terraform to create a virtual machine, you could have it give you whatever public IP address it got assigned or whatever. So now I have this easy reference to go find it. Let me go back to my automation accounts. And there it is. Hey, look, that name looks a little bit familiar. Oh, yeah. Flash AF demo. Okay, great. And then do I have a runbook in there? Hey, look at that. I got a runbook, my Azure automation example. And what does it say? Let's edit it. Hey, look at that. Hello world. Let's go ahead and run it. And like I said, you see how nice the graphical stuff is for Azure Automation? Like if you're just getting started with this stuff and you don't want to go the full bore, this is a really nice way to get started. And here's my output. There it is. So again, the process of clicking and setting all that stuff up and making sure it works and then having to educate somebody else with that, I could do all that, or I could just define it as code and it's there. And when we do pull requests, we can see who's changing it, we all approve it, and then whatever's in the code is what's out there. So it's self-documenting. I don't have to tell you what little things I did because every little thing I did, like that eccentricity, is in the code. Which is great for operations people like me because that drove me crazy, having to deal with unicorns all the time. Sure, all the time. But here's where the testing comes in. So I'm not doing a lot of post-testing on this kind of stuff, but like those Pester tests I did up front to make sure my environment's good, you can just easily, like when it runs this deployment, then go through and make sure everything looks good. Does this database connection work? If I run this test query, does it come back with the right data? All that kind of stuff. So you can know right away if it deployed it correctly or not. And most of the time, like in our deployments, like we just say, okay, start over. Like it was just something transient. Or like I said, like it'll go and something weird will happen in Azure and a resource won't get created and the thing crashes out. Just run Terraform again. Okay, it made it this far, because again, because it can track the state, it goes, refreshes, it goes, okay, I made it, these objects are all here, but these objects aren't here. So unlike a script where it's like, okay, well I'm going to do all this stuff, I'm going to error on this stuff because it's already there, and I'm going to error on this stuff because it's already there, and maybe the guy will figure it out. It'll just go, okay, this is there, not going to do it. This is not there, not going to do it. Okay, this piece is missing, going to build that piece. Now it sounds nice, but that's all assuming that the things that create and delete those pieces are well written, and you can write them yourself. They're not that difficult to do, but the ones from Azure and AWS, like Microsoft has made a huge investment in them. So, and the AWS piece is probably like the most used piece of Terraform. So, so yeah, it works really good. But that's also the staging piece. When you get far enough along this, when you realize that standing up a server is not hiring a dude and waiting a month and paying $50,000 to get that thing racked in a room, when standing up a server is just an API call, that makes it really easy to, okay, build the entire production environment. Every time before code goes out, our entire production environment gets built into a little sandbox. Everything gets tested, and it all gets destroyed. And that costs us like $2, whereas if we were to leave that up, it costs $10,000 a month, But by doing that, we can know exactly what it's going to look like. We use a copy of the production data, as of a snapshot, as of like an hour ago, to know that we're not on a test system that's drifting from the production. Like it's the production data, just a copy of it, that we can delete and screw up all we want. It's not going to affect anything. So there's the Azure automation example. So now let's go to Azure Functions. So my Cloud Shell, if it hasn't timed out again yet. Okay, so now we're on the step to do it in Azure Functions with Terraform. This one I'm going to do 2 scripts. Now the way Azure Functions works is Azure Functions is built on Azure App Service. Azure Functions supports everything like Node, JavaScript, TypeScript, .NET, obviously. .NET Core supports really, really well because it's Microsoft. And so with the Azure Functions version 1 has native PowerShell support. So you don't have to do any of this kind of like packaging a zip like you do with Lambda. It's just here in a folder. Here's my folder, my Azure Function example. And in here, I have my hello world example. So one file in here is this function.json. This just defines the attributes of this function. So all that binding stuff that I was talking about, like this is just simple. HTTP trigger in, doesn't require an API key, and Azure Functions doesn't require you to build all that AWS API gateway infrastructure. It's native to the thing. So like I define that right here, as opposed to having to build all that crap that you saw in the Terraform thing. By the way, one of the nice things about using like serverless and that kind of thing, when I mentioned like the serverless architecture, like the actual program called serverless, is it has all that AWS API stuff. It does the Terraform stuff on that, where you just define, I want this Azure function. And it says, okay, or I want this Lambda function. Okay, well, if you want this Lambda function, that means that you need a gateway. That means that you need this. That means that you need this. And it figures all that stuff out for you. So that's why it was clear about the general purpose versus the specialized tools. So this just defines, I want to have an HTTP trigger in. And when you do that, when the data comes out, whatever my PowerShell function spits out, it saves it to this res file. Whatever it saves to that res file, I want it to come out, back out the HTTP connection. The other options are, like I said, save it to a queue, save it to a storage file, send it to a Microsoft Teams webhook to notify everybody, send an email, hook it up to Microsoft Flow. Sky's the limit. There's a billion options of how you tie all this stuff together. But HTTP is the easiest, so we use that for demos. So, and again, here's another thing where I'm defining how my infrastructure looks in the code. This is not me going into the interface and changing a buried setting and adjusting a environment variable that somebody who comes along after me is like, well, I tried creating it the way he did, but I can't get it to work. And it turns out it was because there was this one registry key that he changed in order to make it work. Well, it's right there. That's what I did. That's the thing I changed. And then here's the actual script. A little more complicated than a typical PowerShell script. With Azure Functions, it's not just outputting to the. If If you output to just your standard PowerShell console, so to speak, that goes into the log. But for what you actually want to return, you have to write it to this file reference that I made, that .res. And whatever you pass to it comes in on this thing called $rec. So these are just two variables. You can rename them whatever you want. It's just rec and res are the defaults. Basically, data comes in on rec, goes out on res. So here's where I'm like, okay, I'm getting all the requests that somebody made, format as a table, and put it out to the log. So if I go to my URL and do, HP warranty $product number equals 1234, that's going to output rec _ query _ product number equals 1234. And that's just an easy debugging thing to be like, okay, I'm seeing it, and now I can work with it just as a normal PowerShell variable. I have an article that covers all that about Azure Functions version 1 called The Missing Manual, which I'll put out. Again, Functions version 1 is experimental, but it works great. Version 2 is really close. I'm actually going to show you version 2 today, but we'll get there. So we're going to go ahead and deploy this one, because this one takes forever. So what this architecture looks like, now that I have that folder, it's just going to push that folder. And then here in my, here's my Terraform. Again, once you learn Terraform once, same deal, just same deal, different data. So I got my, oops, that's automation, function. So for this, I got my things, I got my region, and so I need my resource group. I need a storage account to save my Azure function into. I need an app service plan, which is this is the consumption on demand plan. This is what makes it like Lambda, where you only get billed. This is what gets me that 30, 40 cents thing. You can also run it dedicated, like if those sort of cold starts or you don't want to share infrastructure, like if you want a dedicated virtual machine that's always running ready, you can do that too. It's just, it's not as cost effective. And then here's my actual function app. So here's the meat again. So there's the name, location, resource group, that app service plan I referenced earlier, that storage connection I referenced earlier. And then here's the thing that's an area where here's a limitation of Terraform. Terraform has no idea how to actually publish the document. But what it can do is it has these little hooks. So when I create this, I'm basically telling it, run a local command. And I'm using the Azure CLI to take this function app, deploy it from a zip, and reference the zip that it'll automatically create from that folder. So it automatically creates a zip with this archive file. Where is it? Yeah, where'd you go? Right here it is. That's actually below it. And again, it's below, even though it's below it, because that dependency is there, it'll process first. So this is just me taking that folder and zipping it up. It just says, take that Azure function example, throw it in a zip file. And then, but now I have something that I can reference. So now that I've done that, do this zip deployment. So now let me go back to my Cloud Shell again. It has done all this crazy work. So here's what it's going to create. It's going to create, went through to that thought, okay, going to create all this stuff. Okay, great. And then there creates that, creates the storage account, creates all that, and let me get to, okay, here's at this point where it goes, okay, I created the storage account, and now I'm going to run that command you told me to run, which is AZ function app. So even though this isn't part of Terraform, I can still hook into it to do the things that I need to, and still have Terraform track it. Like, it won't run that again unless the file changes. Whereas with the script, you'd be like, oh, do I need to push it again? Do I need to write check logic? And it just handles it. So now let's go to my function app. And I'm going to tempt fate and go ahead and run my hello world to cold boot it and see if it works. So let me go to my function apps. I showed you this earlier before it was blank. There he is. There's my posh ASDMOTF. Here's my functions. This part. And there's my hello world and my HP warranty function. Exactly as they were in that folder, with exactly the same properties. And then if I go to my thing, hey, look at that. Hello world. Okay, so you're sick of hello worlds. Let's see a real example. So here is a script that I have. This HP warranty module is available on my GitHub. And it basically is a module that has two public commands. You can get enterprise warranties, which is HP split into two companies. The enterprise warranties are the hard ones to get. The regular ones, like desktops, are the easy ones to get. But basically, these are just simple commands that, rather than learn their warranty, if you don't want to learn their API and learn how to use Invoke REST method for all that, I've done the work for you. And so all you got to do is get HP entitlement with this particular command, and it'll just return back all the warranty information. Super easy, super simple. You got a few workstations you want to see if they're up to date. If you want to have it on a batch and you want it to send an email when some of your workstations are within 90 days of ending support, you could write a script in about 3 lines to do that using this module. So I got that module, and then the script is pretty simple. All the script says is get my HP Enterprise warranty entitlement with this product number and this serial number. Oops, I scrolled that a little far. So get it with my product number and serial number. By default, I'm expecting you to provide them as the PN and SN on the URL, which you'll see in a second. If you don't provide it, I just give you a default one. These are like publicly available. Like these are in all of HP's examples, so these aren't like any servers in our environment or any customer's environment. These are just public examples that work. And so product number, serial number, query method. Like I said, I have those two ways. I have the screen scraper way and the heavily unsupported ISEE way. In fact, if you try to do the other way, like it'll throw up this giant warning that says, this is not supported, it will break at any time, possibly. Don't use it in production. We use it in production. But, you know, that's the way it goes. We can support it, so. Warning action, so again, there's that thing. Hey, I don't care. Like, if don't show me that warning. So I do the warning action silently continue. And then what I do is I take it and I convert it to JSON, because it comes out as a PowerShell object. Well, I can't really use a PowerShell object like in an HTML browser, or I can't have another program. Like, if I want somebody else to be able to see this, if I'm writing an API for somebody, they're like, hey, you want to be able to query warranties? Here you go. Here's a standard format that you can understand. It could be XML. I use JSON here because it's easy, and it's less verbose, and it's easier to read, I think. And so that's what I do. I'm just converting that PowerShell object to JSON using a function that's in PowerShell. It will take any object and convert it to JSON. And I'm skipping the compression step. And then take that and write it out to that special res object I told you about before. That's what I write to, and basically whatever you write there goes straight out to the browser, or whatever your output angle is. So let me go to my demo links here. Let's try just the default HP warranty. And so you can see up here at the top, it's just the base URL there. Moment of truth, this will probably break. It takes a second the first time usually. What it's doing is that it's firing up the virtual machine. Okay, there you go. So now, rather than have to learn PowerShell, let's say I have a user, and rather than have to teach them PowerShell, teach them how to use get HP warranty entitlement, teach them how to do all that kind of stuff. Hey, here's the URL. Use whatever language you want. I don't care. Node.js, Java, C#, whatever. You know how to use REST APIs? There you go. Go here, parse that out, do whatever you need with it. And I don't care who does it. I can just make it available in my company. Hey, if you think of something that this is useful for, knock yourself out. We'll watch our analytics to see if anybody actually uses it. So this is an ugly JSON. I'll make it a pretty JSON. Let's do a new file here. Show off a little bit more VS Code. Format document. Oh, it helps if I tell that that's a JSON document, not a PowerShell document. I got this big, ugly, long string. Format document. Hey, look at that. Much easier to read. And there you go. There's my system, my serial number, my product number with a product description. I didn't give that. That came out of the info. When does the warranty expire? Okay, warranty expired in 2011. Oh, we should probably pull this thing off the shelves. It started in 2008, so it had a good 3-year run, We didn't. Now, did we update, oh, we got a base warranty. If we had additional contracts they'd show in here. All this comes straight from the HP API. Just uses my script. And all my script does is literally call their API. And so, but that just pulls it through. So now I have this. I could write a script that has 100 of them. Let me just do another demo link here with my custom serial number. So again, exact same link, only this time I did a query. I said, okay, here's a serial number, and here's a product number. And you'll notice it queried that serial number and that product number. And this time I got an HP P2003G3, which is a storage array. And there you go. So that gives you an idea. And you can query that once. You query that 1,000 times, it'll spin up 10 workers, and they'll all hammer HP's site and bring the information back. And if they don't have an API limiter, then okay. All this stuff, now I'm showing like the really raw way of doing this. Obviously, you can protect this with Azure AD. You can require API keys. There's lots of really advanced stuff you can do to protect this API. Limited by geographical region, whatever. Really, all kinds of stuff. But this just shows how you can do this in PowerShell. Like that's PowerShell, all of it. It's not, I didn't have to write a custom Java framework. I didn't have to drop into .NET. It's all just native PowerShell. So you can do all the same kind of web API type stuff that's required for that. So let's do one last thing on my demo, and then I got one other thing to show, and then we'll wrap it up. So we go back to my Cloud Shell. So now the final thing to do is destroy it all. I'm going to skip this step this time. Just going to let it do it here. Here's my warning. I require you to type burn it down to destroy everything. But again, it's not going to destroy everything in Azure because it's Terraform. It's only going to destroy what Terraform created. It's smart. Whereas if you run a script that does remove item, you know, with a particular name and a star, maybe somebody created something after you that has that same name as a star, they created -test, suddenly you've screwed up somebody else's project. Yet again, why that kind of declarative things versus procedural scripts, why it's a really great thing to move to when you're working beyond just like an IT team of one. Okay, so it skipped it because I didn't type burn it down. But I'm going to run the whole thing again, only I'm going to do it the faster way. So this build.ps1, this might be something interesting. If you go in here and look at this is just a wrapper script that I wrote that checks for invoke build. If invoke build's not present, silently downloads it in the background and starts it. So basically it's a way to build power. I put this in here because anybody, as soon as you download it, you can run build ps1. If you don't have invoke build installed, it'll figure it out. I don't require you to learn how to use invoke build or even know how to install a PowerShell module. It'll figure it out. So we'll do that. Take this PowerShell Core. So now you'll notice it'll skip a bunch of stuff too. It'll skip a lot of the test steps because a lot of the things have dependencies and they'll say, oh, we already tested this, so we don't need to do it. So here's this, where is it right there? Right there, test Azure. You see how it's gray? That's because up here, it already tested Azure. So it doesn't repeat it. And again, that's one of the nice things about invoke build. I didn't have to tell it to do that. It just knew it because this thing was dependent on this. Now it's doing them in order. So now it's running. It's refreshing the state of that. We're doing the Azure automation one first. Actually, here's the Azure function already did it. Yeah, I forget this thing works fast. So here's Terraform where, let's check the Azure function. Okay, let's do it. We refresh the information about it. No changes. So I ran the exact same script. No changes. You didn't see me edit anything. Only this time it didn't do anything. Because again, it tracks the state and it knows that nothing's changed. So it's idempotent, that's the fact that you can run it over and over and over again, and it's not going to create multiple duplicate resources or error if something already exists. And it does it for the other one. That's up to date too. Great. This one's actually going to update because the function, because of the way that it builds the file hash always changes every time it builds it. If I disabled that build step, this would not change it. But here it says, okay, that zip file changed. I'm going to go ahead and upload the change. And so then it does it. And that's it. So that whole script took 60 seconds to do in those documents that I showed you, and then some. Like, if you go to that manual page, go through every single one of those documents and do everything step by step. Measure how long it takes you. Compare that to 60 seconds. All right, now we're going to do the fun one. Build.ps1 destroy. Burn it down. This is going to go through and destroy everything. Oh, well, it's going to want my region. I require this as a little thing, so make sure you're in the right region. And so all that stuff that I created, there it goes. It's first making sure it's there, destroying, 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 destroying. AWS always goes super fast. Azure takes fucking forever. I hate their API so much. But it'll get there. There we go. Found it. Destroying, destroying, destroying. But again, it's doing it from that state file. It's only destroying the stuff that I created. I have other stuff in there that it's not going to destroy, so. This is my favorite message in Terraform. Still destroying. Okay, so that's running. That's going to go through and trash everything. And if I go in here, like if I start refreshing this stuff, it's going to be gone. So I think the automation account was already done. There, it's gone. Function app. Gone. Well, it's still working on that one because it takes forever. But if I go to Lambda, see, it's gone. So this is the one I had there previously that I was testing with. So that repository is available. I'll provide a link to it. And again, that's an easy way to play with it. These two accounts that I'm using are just two free accounts that I set up like 2 days ago under just a personal email address. Everything works free. Everything that gets created is under the free tiers. And so it'll work completely free for a year, everything it creates. And so you can test, build PowerShell functions, build advanced PowerShell functions, all that kind of stuff. So the last thing I'm going to show is, I was hoping it would be released by now, and it's getting there, but is Azure Functions version 2. So let me pull up an article here because there's a graphic I want to show. There should be there we go, introducing. Yeah, this one. Okay, so this is the main difference. used to be, and also this runs on Windows, this runs on Linux. So it used to be that you had this thing, it would start the .NET framework, and then everything ran on top of that one .NET framework thing, and it just interpreted it. The new design is that everything runs in .NET Core, and then each individual language is implemented as its own worker process. So Python, Node.js, PowerShell, they're all now, remember we were talking about microservices? As opposed to having to wait for these guys to get their crap together to get a test to build. Now each of these are developed separately. They have their own GitHubs, whole 9 yards, including the PowerShell worker. So the PowerShell worker has its own dedicated GitHub being worked on, and it's going to be released hopefully pretty soon. It's at release candidate stage. It's almost a preview where you'll actually be able to use it in Azure. But you can use it today. You just have to go to their GitHub, download it, and then download the functions worker, which is basically like, you can have all of Azure Functions on your laptop. They have a runtime that runs everything in Azure Functions like it was Azure Functions. So here on my desktop, I'm going to switch to my other window here, my PS Core app example. So here's just an example with a couple things, an HTTP trigger, a couple modules, a Bitcoin module, which does some Bitcoin currency conversions. And let me bring up a command prompt, PowerShell. Come back. So in order to start this, I just do func start in the directory. Once you have it all installed and everything. So this is going to fire up the monitor, and what I have here is, here's my 3 URLs. So this is Azure Functions running on my local laptop. You could put this on a server if you wanted to for development. And here's my 3 test links. So let me go here and run my function version 2. So here, up here, there it hit my local host on my address, API, same syntax as you saw before. And all this function does is just echo back to me whatever I put for the name parameter. Hello, Dave. Back. So once this is production, you can test it here and make sure it's all good before you push it out. Like, this is what we do for our things with the version 1 is when we develop it, we run it, and it goes through the whole test suite, including like the test against production data and everything, before it even leaves our laptop to then go to staging, to then go to production. Which sounds like a lot of work, but we don't do any of it. I just hit commit. I just say new feature this, and I hit commit. And I get an email if it says, oh, you screwed up. The build failed on this test. Not from a coworker, just from the system. I hate that system. It's so mean. It's so detail-oriented. Okay, simple echo thing, basically a hello world, boring. Let's do something a little fancier. Let's take this, let's find out what the current price of Bitcoin is in US. There you go. Blow that up a bit. All right, from Bitcoin to US, here we go. Price is that. Here's the last time it was updated. All this stuff. I just made an API in like 2 lines of PowerShell that somebody could consume, or I could consume if I needed to. I could have this up and running, and like, again, I'm doing this in a web browser, but I can just open up a PowerShell prompt here real quick. My favorite little guy here. Let it take forever because my peers don't have it with me. Invoke, REST method, same URL. Well, it helps if I put it in quotes. I hate that about this version of PowerShell. Hey, look at that. I got a PowerShell object back with all this information. Hey, let's put it into OutGrid view. Hey, look at that. So there you go. There's no excuse to not be able to use PowerShell in a web environment just as strongly as you can anything else. I'll show one real-world example here. This is a live application for all the traffic planning in Los Angeles. This shows a farm of modeling servers and where the model is, who's working on it, how long the person's been working on it, how long that model's been running. This all gets parsed out of the modeling system's log file. What loop it's on, what activity it's on, what step that model is on, and all these are RDP links to get to them. All of that is a single-page application. You see how fast that came up, by the way? It's because this is a single-page application that processes entirely in the browser, reading this data.json file, which gets updated about every 5 minutes. Look familiar? Hey, it looks like something that came out of maybe an Azure function, right? It is. There's an Azure function that runs every 5 minutes out in Azure that costs nothing, basically nothing, that every 5 minutes initiates a PowerShell remote session. First it goes to AWS, queries the AWS API to say, show me all the modeling servers that have been generated by Terraform. All these servers are generated by Terraform. And then set up with PowerShell DSC. Give me a list of all the modeling servers that are out there. Okay, they're all set up with PowerShell remoting. So then it establishes a PowerShell remote connection and then pulls all the information about them that's required. What's their public IP? What's their current state? Where's the modeling at? Does all the information, takes it, formats it, puts it in this nice JSON format, which these are just PowerShell PS custom objects. So just make a PS custom object and then pipe it into convert JSON. That's all this output is. And then just pipe it out. And so that takes that, and rather than pipe it out to the web, pipes it out to this file on an S3 bucket. And then this website just reads that and puts it into a data table. So I look at the code. The code is not very complicated. If I can get a good view of it. Like, this is the code. It's not very complicated because I am a terrible web designer. I'm awful at it. I'm horrible. I am so bad at JavaScript and stuff. But I know just enough to be dangerous. I know just enough to pull in a bunch of these frameworks. I know just enough how to Google how to put this kind. Okay, I can do this HTML stuff. I'm good at this stuff. This stuff, not so much. Okay, this took me probably like 3 days to figure out just how to do a standard data tables that some web designer guy would laugh at me. But in about 3 days, I have a fully functional single-page application that updates. I'd like to see that web guy do the back-end work on this, to go pull all that information from all those servers, read their current status, read their uptime, read the log file off that. I'd like to see you do that in Node.js in half a day. So we all have our values, and you can use anything that he can, I could have just done the back-end stuff, and because of the microservices aspect of it, gave the web designer, look, here's the data, you figure out the pretty way to do it. But we didn't have anybody available, so I had to figure it out. So that's my spiel. I hope that shows a real good view of all the different places you can run PowerShell. That's not just your local machine or just some server on a scheduled task somewhere. There's a lot of real available places to use this as a powerful production computing atmosphere. And the great thing about serverless computing is whether you use PowerShell, whether you use Node.js, it's all based on how much you use it. So if you have intermittent things that need to run occasionally, if you don't need to reserve that server and you can write it there, not only do you not have to worry about the server and the upkeep and if the server services are running, because that all gets handled by the serverless infrastructure, but it's also dirt cheap. You can write some pretty amazing stuff that costs basically nothing and save your company a ton of money, save yourself a ton of money, get a competitive advantage on your opponents. So thank you very much. Questions? XYZs?
Yes. Thank you. Okay, so that was really great. Taking PowerShell to Azure Functions, like when Azure Functions were first coming along and Aws Lambda was first coming along, everybody was like, hey, let's go play in this Node.js playground, let's go play in this C# playground. And all of us PowerShell people were sad. But we're not sad anymore because you can take all of that stuff to the cloud now, and it's great. So thanks, Justin, for showing us how to do that. Thanks everybody who watched online. This is the point where we're going to shut down the stream, and we'll do some of the in-person business here. But I want to thank the sponsors again. Thank you to Viewpoint, and thank you to Sapien. And we'll see you again next time. Thanks.